Good afternoon. This is an E570 energy utilization tutorial on AC distribution calculations. Now, what I want us to look at is a question in assignment 1, 2021. The question in particular is this one. This is the actual question. It's question 3 in assignment 1 for 2021, electromechanical engineering, energy utilization EE570. And it says a 3-phase 138 kilovolts delta 13.8 kilovolts Y distribution substation transformer rated 40 MVA for OA and 50 MVA for FA, as well as 65 MVA for FOA, has an impedance of 8%. The first part requires us to determine the rated current. The second part requires us to find the per unit impedance at a base of 100 MVA. And the third part asks us to calculate the short circuit current of the primary 3 distribution side of the transformer for a 3-phase bolted fault. And it says assume the pre-fault voltage to be 13.8 kilovolts. So let's begin. So take note that this is coming from the book Power System Analysis and Design, Duncan Glover. This question was actually taken from this book, Power System Analysis and Design by Duncan Glover and some other author. The chapter is chapter 14 under power distribution. So there are a few things that we need to know concerning the question before we even begin to solve it. And that's the fact that there are 3 important formulas that are going to be required in order for us to actually solve this question. So let's collect the data. So real quickly, I think we can just pause the video for a bit so that you can collect the data as well. So this is the question. You can pause the video and simply collect the data, then we continue. So from the question, we have a 3-phase distribution transformer . It's rated 138 kilovolts over 13.8 kilovolts, and it's delta / Y. Next, we have the different ratings that it has, which is a rating for OA, FA, and of course FOA. So in a second I'm going to explain what this simply means, but for now we'll just collect the ratings. So the rating for OA is SOA, where S is the complex power, is 40 MVA. For FA, its SFA is 50 MVA. And for FOA, SFOA, it's 65 MVA. The other thing given is the per unit impedance in percentage. So we have Z, percentage Z is equals to 8%. This simply means that Z per unit is 8 out of 100. 8 over 100, which gives us 0.08 per unit. So this is pretty much it. But now I want to explain on what these symbols OA, FA, and FOA mean. Now these are all on the same transformer. So now real quickly, let me just go through what this means.
Yeah, so for the transformer, OA, FA, and FOA simply imply cooling method. So these symbols represent what type of cooling method is being used. Now, in any cooling method, your transformer could be filled with oil, mineral oil, and the outside, of course, is surrounded by air. So let's say this is your transformer. This is the tank that houses your transformer. Yeah, and on the inside you have the windings of the transformer. Now, inside this tank we have some mineral oil. And outside all we have is air. Hence the symbol A and O appearing on these types of cooling methods. Now, what could happen is on the inside, in order to cool the transformer, the oil could either move by natural convection or by forced convection. What that simply means is it could be moving on its own due to the heat that it absorbs from the windings of the transformer, or it could be moving due to the power of a pump or some pumps that are inside the transformer or that are used to circulate the oil so as to make the convection process much faster. The same can be said for the air. It could move around here and cool the transformer on its own by natural means, or it could cool the transformer through the use of fans. So you might find that certain transformers have fans on the outside that are installed to actually allow the air to circulate. So when we say OA, it simply means that if this transformer has a pump, or it has a pump inside and fans on the outside, the pumps are off and so are the fans. So all you have is simply oil and air circulating by natural means. If you have FA, it means your pump. Yeah, so if you have FA, this could imply forced air, which simply means that your pump is off inside, so the oil is moving on its own, but the fans are on and they are forcing the air to circulate. So you could take this as forced air. Then FOA simply implies, in this particular book, simply implies that both the pump and the fans are on. So the air inside is circulating due to the pumping action and the fan action. So the pump inside, or the pumps inside, are driving the oil, the mineral oil, around the windings and helping to improve convection cooling. And the air outside is also being driven by the fans outside, causing the convection rate to even increase. So that's all these three things mean. Now, if a transformer has probably, I'm assuming this is what this means, if a transformer probably has pumps and fans, you could either operate it with the pumps and fans off, that's this, with the fans on but the pumps off, and with both of them on and off. And each of these conditions has its own S rating. So it has SOA. Hence, in our question, I think our SOA was 40 MVA, and our SFA was 50 MVA. SFOA was 65 MVA. Yeah, these are simply telling you the different ratings that it would have depending on whether it's using this type of cooling method, this type of cooling method, or this type of cooling method. And that's all that it means. Yeah, so I've explained on cooling method, but now I need to explain on how to go about solving each part of the question individually. So I think at this particular point in time, this video ends here.